Alright, today we're looking at graphing exponential functions, and we've actually already done this once before this year, but we used a very specific type of exponential function. We used the 2 to the x power function. Now we're going to use several different types of functions. So the very first thing you need to do on question number 1, okay, question number 1 actually is a 2 to the x function. You would have done this earlier in the year. You need to know your points. Okay, so when we did this the first time, we had a very specific set of points we used. I don't know if you remember what they were, but it was -1, 0, 1, and 2. And then we used the points. This was 1/2, 1, 2, and 4. Okay, well, now that you know a little bit more about exponents and stuff, you should kind of understand a little more where these points come from. I am talking about for this function, where it's just 2 to the x power. Well, if I put in a -1 for x, you should know now that that means 1 over whatever that number is, so in this case 2. 0, if you plug anything in for 0, you're going to get a 1, so this is always going to be 1 to start with. Plug in 1, you get 2, plug in 2, you get 4. If we chose to do 3, it would be 8. That's getting close to being off our graph. After that, you're just doing your normal transformations with any number in front. So this is a stretch, okay? And if you remember about our stretches, I'm going to write that down. That's a stretch. Your stretch actually multiplies your y value by that number. So each one of these y values is going to get multiplied by 3. That's going to make this a 3/2, 3, 6, and 12, okay? Once you have those points, then I can graph this equation. So that's -1, 1.5, 0, 3, 1, and 6. 1, 2, 3, 4, 5, 6. And those are probably all the points I can get on this graph. I could, if I wanted to, add when x is -2 on here. You should know now that when x is -2, that's going to be a 1/4. If I do 1/4 times 3, then that's going to be 3/4 or 0.75. So it'll be a little down here. It's going to keep getting closer and closer to the x-axis, but if you remember, it's never going to cross the x-axis, okay? It doesn't matter how small I make that exponent, how many roots I take of 2, I'm never going to get a negative number. So we just connect those dots, and I have graphed this function. Your domain is still all real numbers. I could plug any number in for that exponent, but if you remember, your range for a exponential function is going to be y is greater than 0, not equal to 0, because again, it's never going to get to 0. That's actually what we call an asymptote. We're going to talk about that later on, but that is your horizontal asymptote, okay? So same thing when I get to question number 2, except my chart's going to be a little different to start with. So I start with, what does 3 to the x look like? So again, x and y. I like to use the same -1, 0, 1, and 2. I think that usually gives you a good enough picture of what your graph's going to do. Okay. Again, if I do 3 to the -1, that's going to be 1/3. 3 to the 0 is 1. 3 to the 1 is 3. 3 squared is 9. Okay. Just like the last one, this 1/3 is going to multiply all of these values by 1/3. Okay. Well, 1/3 times 1/3 is actually 1/9. 1 times 1/3 is 1/3. 3 times 1/3 is 1. 9 times 1/3 is 3. I can just plot those points. So at -1, I'm at 1/9, which is way down here. At 0, I'm at 1/3, still down here. At 1, I'm at 1. At 2, I'm at 1, 2, 3. If we wanted to keep going, 3, you should know, is 27. If you did 27 times 1/3, that's going to be 9, so you could fit that one on there. But again, I think these 4 points are a good enough representation of what your graph looks like. Okay. Same thing with our domain, all real numbers. Range, y is greater than 0. Okay. Same thing if I was going to do this next one. Again, x and y, -1, 0, 1, and 2. If I do 5 to the -1 power, 1/5. 5 to the 0 is 1, 5 to the first is 5, 5 to the second is 25, okay? Again, I'm going to multiply all these by 0.25, okay? Well, it may help to know 0.25 is 1/4, so if that helps you, you could do that too. 1/5 times 1/4 is actually 1/20th. Joke's on me. 1/4 times 1 is 1/4. 1/4 times 5 is 5/4. 1/4 times 25 is 25/4. So some of those fractions are pretty gross. That's okay, we can still work with them. 1/20th, way down here, way down here. 1/4, also pretty down here. 5/4 is going to be 1 1/4. So I'm a little more than 1, but not quite to 1 1/2. 25/4 is going to be 6 1/4, right? 4 goes into 25 6 times. So that's 1, 2, 3, 4, 5, 6, and a little bit more. Okay. Again, I think those are good enough points to get kind of the general shape of this graph. Domain still all real numbers. Range is still y is greater than 0. Okay. I'm going to let you say if you want to work number 4 on your own. Okay, but your chart is going to be very similar to this one to start with, right? Because it's still 3 to the x. This time, instead of 1/3ing those points, you're going to double those points. So when you do that, you know, if you want to go ahead and pause the video and go ahead and do what you need to do to practice for yourself, but it's going to be -1 2/3, 0 and 2, 1 and 1, 2, 3, 4, 5, 6, and then that's just about all the points you can get on this graph. Again, domain is all real numbers, range is y is greater than 0. All right, a little bit of a change here. So first of all, I still need to do my 4 to the x graph. So that's x and y. Again, -1, 0, 1, and 2. 4 to the negative 1's 1/4. 0 to the, or 4 to the 0 power is 1. 4 to the first is 4. 4 squared is 16. Okay, what does a -2 out here do? Well, if you remember from your transformations, that's going to go down 2. Okay, so I'm going to take this point, -1, 1/4, and I'm going to move it down 1, 2. Okay, I'm going to take the point 0, 1, and I'm going to move it down 1, 2. I'm going to take the point 1, 4, I'm going to move it down 1, 2. And if I could fit 16, I would do the same thing here. If you keep going, when you draw your graph this time, it's going to be down here, because I have moved that asymptote of 0 down here to -2, because we moved the whole graph down 2. So when I write down my domain and range, domain is still all real numbers. Your range is going to be y is greater than -2, but again, not equal to. Okay. If it helps you to, just like we multiplied these by 1/3, if you would rather sit here and subtract each of these by 2 and try to plot your points like that instead of doing what I just did, feel free to do that too. Okay. Question 6 is again a 2 to the x graph, so we've already done that table. -1, 0, 1, and 2. That is 1/2, 1, 2, and 4. This time, since that's an x plus 5, since it's a tiny plus 5, that's considered inside. If you remember what that does, that moves it left 5, like the graph wasn't a big giveaway. So again, I'm going to take these and move them left 5. So instead of being at -1, 1/2, I'm going to move left 1, 2, 3, 4, 5. Instead of being at 0, 1, I'm going to move 1, 2, 3, 4, 5. Okay, instead of being at 1, 2, I'm going to move over 1, 2, 3, 4, 5. And instead of being at 2, 4, I'm going to move over 1, 2, 3, 4, 5. You also could have just adjusted based on this. If you knew this was this point, you could have just said, hey, that's my new 0, 1, and plotted the rest of the points from there. You just have to kind of be careful with that because it's not your new 0, 0 like what we usually use. Okay. Domain on this one, again, hasn't changed. Range is also still y is greater than 0 because I haven't moved it up or down. Okay? So that's the front. If you tuned out, I should have mentioned this earlier, you should flip to the back for sure first because this is just a tiny bit different. Okay? Not exactly, but a little bit. So this time I have to, when I make my chart, think about 1/2 to the power. Okay, so 1/2 to the power. So on this one, since these are fractions, I actually like to use the points -2, -1, 0, 1, and maybe not 2. You can use 2 if you want to. But the reason for this is because if I have if I have 1/2 to the, let's say, first power to start, 1/2 to the first power is just 1/2. If I had to put 1/2 to the second power, which I usually don't, but 1/2 to the second power is 1/4, I would keep going 1/8. Those are just getting a lot smaller, so it's they're not that much help when I'm trying to graph. Still, anything to the 0 power is just 1. 1/2 to the negative first power, if you remember, that's 1 over. If I do 1 over 1/2, that's the same thing as having 2. Okay? And 1 over 1/2 squared is the same thing as flipping it and squaring it. So that's going to be 4. So I do think those points are a little more helpful than keeping on going with like 2 and 3 and stuff like that. Okay? Again, though, like the last time, the 6 is going to multiply all these y values times 6. So maybe we could have used the 1/4 this time. If it helps, go ahead and do that. That's 24. That is not going to be able to graph. That's 12. That's really not going to be able to graph. 0, 6 is probably the first one I could graph. 1, 2, 3, 4, 5, 6. 1/2 times 6 is going to be 3. So that's 1, 1, 2, 3. In this case, we can do 1/4 times 6 is going to be 3/2, so that's 1.5, 1.5. If I kept going, if you remember, 3 would be 1/8. 1/8 times 6 would be, what is that, 3/4? So 3/4 would be, and it's going to keep getting closer and closer, just like the last one did. If you notice the difference, the big difference between this graph, your domain is still all real numbers, the range is still y is greater than 0, but the big difference is this one is decreasing. Okay, so we call this exponentially decreasing. That's because the number inside here is a number less than 1. When the number inside there is a number greater than 1, it's just going to increase exponentially. And that makes sense if you think about what you're really doing when you're exponentially moving something. So let's do, like, I don't know, maybe 1 or 2 more. I don't really want to do all these. Let's do this one here. This is a good one. So first of all, here's your points again, x and y. I like to, again, -2, -1, 0, and 1. Okay. When I put in 1, so 1/4 to the first power is just 1/4. 1/4 to the 0 power is just 1. 1/4 to the negative first power is 4. 1/4 to the -2 power is 16. Okay. Again, this number in front is going to multiply all of these. So if I multiply all these by a -2, this is going to be a -1/2. That's going to be -2, -8, and -32. Like I could even graph that if I wanted to. So 1 is at -1/2. 0 is at -2. -1 is at -1, 2, 3, 4, 5, 6, 7, 8. That's convenient. And then it's going to keep going from there. So I can't go any further that way. But I can flatten it out this way because I know that's what it's going to do. So notice this one has been reflected, and you should have known that that was going to happen because that's a negative. Domain is still all real numbers. Range, this time y is less than 0 because it has been reflected. Okay. If I was going to do the next one, I would actually suggest doing fractions on this instead of doing the decimal. I don't think I'm going to finish this because I don't really think you have that many like that on your homework. But if you have any more questions on any of these, ask during class. Let's do review just a little bit down here on what this one's going to do. Remember that that's going to go to the right 1, so that's this way 1, and up 2. Just kind of reviewing transformations in general. Plus 3 minus 1 is going to be left 3 and down 1. Minus 5 and plus 6 is again going to be right 5 and up 6. Just kind of reviewing that. Remember, a negative in front is a reflection, and you multiply the y values by whatever that is. Okay? Cool.